Hello, gang. So the other day I was saying this Steve Reich piece of reading that hopefully you've done now. Music as a gradual process has been really influential to me, and I think it's a really interesting piece of writing. Um, One of the pieces that he made that hopefully you've seen by now, called Pendulum Music, I think is the most uh, um, holds most clearly to those ideas. And it's a piece that's not really that amazing to experience, as I'm sure you've seen. Much like this little thing that I made here, it's not that pretty in a lot of ways, but it was fun to make. And I think in general, these ideas, this music has a generative process, process oriented artwork like this one, does best when it's sort of one part of the piece. But I do think it's fun and interesting and evocative and can help us learn how to do some interesting stuff. So, what we're going to do is we're going to make these pendulums. And I think it's going to be fun. We're going to do it with no classes. And this is probably going to be 3 videos. Um, First, before we can get down to these pendulums, what we need to do is we need to understand harmonic or sinusoidal motion. And you can see here, this is some circles moving in circles, right? How do we do that? How do we create this sort of motion? We use sinusoidal motion. This is basically a sine wave, like the one you see here on the left, but it's a sine wave that's mapped onto a grid. So it might seem a little bit hard to understand what's exactly happening there. And there's another. I put another link on today's syllabus to this piece that I made, where we have this wave-like thing happening. Right, it's the approximation of a wave, and waves. I think waves are so fascinating. Um, in that they are, each particle is not actually moving along. There's not like a particle that starts over here and makes it over here. Every particle stays in place and just rubs against its neighbor and pushes its neighbor forward a little bit. Those particles just move in a tight circle, like here. So those particles just move in a circle and they sort of nudge each other and they create this illusion of a wave. So these waves exist in nature. Sound waves are waves, and waves also those sinusoidal waves are how we generate this kind of pendulum motion as well. So in order to understand how to do that, we need to understand this sine function. And what's a sine function? A sine function is coming from trigonometry. A sine function is the value of the opposite and the hypotenuse, I think. Or maybe that's the cosine. Anyway, it's the value of two of these sides, one side divided over the other. And basically, the angle is traced here. The angle goes from it goes up there, and it goes down there, and that entire range is the range 2 pi. This is pi up to there and down to there and then down to there. So the sine of this angle generates these points. And you can see we can also generate a circular motion by mapping the sine to the x and the cosine to the y. This might all seem kind of abstract, so let's go ahead and start here. Let's make just this sine wave. So we'll see a mapping of this sine function, and maybe that'll help understand how what we need to do. So I actually already did this once before because I don't seem to be very good at making videos today. So I'm gonna make a new folder, and gosh, I can't even find my folders anymore. There we go. So we're gonna make a new folder, and I'm gonna bring in a P5 library and an index.html. And I want you to do the same. I'm not going to give you any starting scaffolding or anything like that. So you may want to pause the video here and work on assembling that, unless you've got it close at hand. All right, so let's go ahead, and you can also use the P5 editor if you prefer. Just make a new sketch. So we're gonna code through some of these ideas here. We're gonna make this sine wave, and I'm not gonna use any classes because I know I promised y'all that I wasn't gonna use classes, at least for a little while. Okay, it's not like I've given up drinking forever or given up classes forever, but for a little while I'm gonna go class free here. So I'm gonna make this sketch.js, and we're gonna make this form here. So what I'm gonna do is create canvas width, and I'm gonna make a canvas height. And I'm going to get rid of this typo, right? And so now we're going to have this canvas width and this canvas height. And in our function setup, I'm going to create a canvas. And, you know, part of the reason I didn't want to give you any scaffolding this time around is because this is going to be somewhat straightforward, what we're going to do here. And part of it is because I just want you to be able to start on a blank page and write a poem, write a little code poem, because I think that's a tremendously, it feels good when you get to the place where you feel pretty comfortable just doing that. And I want y'all to get there. So I'm going to pass the canvas width and the canvas height into this create canvas function that's going to create me a canvas. And I'm going to draw a background and give the background just a dark background. So let's just open this up and see if I've got something. Okay, good, I do. And so I've got my background, and I'm going to go ahead and this is all going to be in this sketch.js. So I'm going to just keep this over here, and we'll keep this over here. And what we want to do is we want to use that sine function to create our y values. And you know what I'm going to do is I'm going to make a function called create circle. And right. I'm mixing idioms. I'm going to use an arrow function. It's going to be called create circle. And what it's going to do is we'll bring in we'll not bring anything in for a second. We'll just return an x, and let's just set that to canvas width over 2, and we'll return a y, and we'll return a color. Oops, you know what I should do is let's do a size and our color like that. So again, I said I'm not going to use classes, but I am going to try and keep my data organized. I'm going to write functions. I'm not just going to draw my stuff in here. So instead of ellipse in here, I'll make a draw circle as well. But let's go ahead and make a global variable called circle in here and set up. I'm going to say circle equals create circle. So I'm going to use a function to generate this circle. You can see it returns an object. It's going to have an x and a y and a size and a color. And then I can draw that circle. So we'll say and in here we'll just say fill, and this is going to be circle.color, and we'll say ellipse circle.x circle.y, circle.size. And look, we get our circle. So nice, right? Now, if we want to move this circle, we can also do that. Let's do that. Let's write a update circle function. And now we'll move this circle. We'll say let's say circle dot y equals sine of an angle plus a wave height, no, times a wave height plus circle dot origin dot x dot y. You know what? We don't even need it. Let's just do this like this. Canvas height over 2. And we can put those somewhere in a sec, but we're gonna just say here, well, let's make our wave height. We'll say const wave height equals 200 and let angle. We'll let angle equal 0, but in our draw loop, we're going to increment it. And when we update our circle, we're actually going to pass in that angle. So I'm going to add that here. And now, so we're gonna use this sine function. We're gonna multiply that. So our sine function is always gonna return a value between -1.0 and 1.0. So all those fractional points in between, and we can multiply it by some like limiting value here, which is gonna be 200. So we're gonna have a wave height that's gonna go from 200 to -200. And then what we're going to do is add canvas height over 2 because that's where it currently is. So let's take a look and see if it works. Yeah, looks like it's doing pretty good. So we're going back and forth. We can also increment circle.x. And let's just say circle.x equals angle. All right, let's see now. So now, let's say angle times 10. All right, and now we see it's moving forward a little bit. It's not moving as forward as fast as I want. And there we go. Now we're getting this. We're getting the tracings of this wave. And if we just stop drawing our background, actually, we can see it. There's our sine wave. Pretty neat, huh? If we wanted to draw a circle, instead of incrementing this x in this regular fashion, we could actually use the cosine of this angle. Keep everything the same, and now we get circular motion around this central point. And let's make this canvas width over 2. Around this central point, we're drawing periodic motion. Now, we're not quite doing what I said we would do here, where we would draw out all these circles. I'm going to leave that as a challenge for you right here. I'm going to say I'll be back in a bit with the next video, or you know, the video's already there actually for you. But what I want you to do is try to do it on your own to create. So we'll go back, we'll get rid of this circular motion. We'll say instead this is going to be angle times 100, or times 10. And we're going to, what I want you to do is I want you to, instead of updating that circle, when you create these circles, I want you to create an array of circles that are located at regularly spaced intervals on the x-axis and utilize this sine function on this y-axis. And then what I want you to do is use, instead of creating just a circle, say circles equals array dot from length, and let's go ahead and make that 255, and we're going to return this value. But you need to rewrite this, like I said, to utilize this I and create this pattern. So see if you can do it, and I'll be back in a minute to show you how I did it. All right.